Hi everybody, let's talk about dilutions. So what does it mean to dilute a solution? Well, that means to make it less concentrated. And how do you do that? Usually by adding more of your solvent to it. So a concentrated solution means that it has a relatively high amount of solute, whereas a dilute solution means that it has a relatively small amount of solute in a given solvent. So let's write that down. Relatively large amount of solute in a given amount of solvent. This one, same thing, but small amount of solute in a given amount of solvent. Okay, so let's take a look at a solution. So I have this solution right here. It's a copper sulfate solution. It has a certain concentration, has a certain volume, has a certain color, and so on. So I'm going to dilute this. How do I dilute it? Well, I can add water to it. So I'm going to go ahead and add a bunch of water to it, which is my solvent. And so now I have solution 2. Solution 2. So solution 1 was the one that was concentrated. This is the dilute solution, so I'm going to call this solution 2. So it has a certain color, certain volume, certain concentration, and so on. What is different and what's the same about both solutions? The first one that was not diluted, and then this one that is diluted. Well, they have different concentrations, obviously. This one's less concentrated. They have different colors. This one's a lighter color. They have different volumes, right? This has a higher volume. But what is the same about both of them? Well, I only added water to make solution 2, right? So I did not change how much of my solute I have. So the only thing that's the same about them is the moles of solute in solution 1 is the same as the moles of solute in solution 2. So from that, we can come up with the molarity equation. The molarity equation is M1V1 equals M2V2. And let's talk about how we can come up with this and how it's okay to say that. So M1 and V1 are the molarity and the volume of the first solution, the one that was not diluted, right? So molarity is moles of solute over liters of solution. So moles of solute in the first solution divided by its volume. That is my M1. My V1 is volume, so it's in liters, right? So that's the left side of the equation. Let's look at the right side. The right side is moles of solute in the second solution per liter. And then we're going to multiply that by V2, which is in liters. If you look at this equation, liters 1 and 1 cancel, and liters 2 and 2 cancel. You get that moles of solute 1 is equal to moles of solute 2, which is what we had established, that my moles of solute in my concentrated one are equal to the moles of solute in my dilute one. And so whenever you see a dilution problem, you use M1V1 equals M2V2. So let's look at this one together. It says if 5 milliliters of 12 molar HCl is added to 195 milliliters of water to give a 200 milliliter solution total, what is the molarity of the dilute solution? So we have this concentrated solution. It's 12 molar. That's very strong. And we only have 5 milliliters of it. We're going to take those 5 milliliters and we're going to add 195 milliliters of water. So that the total volume would be 200 milliliters. So this is my second solution. We want to know what is the molarity of that second solution. So we see that it's talking about dilution. So we say M1V1 equals M2V2. It doesn't matter which solution you pick as solution 1 and which one you pick as solution 2. I'm going to pick the one that is boxed right here as my solution 1. So my molarity of solution 1 is 12 molar. My volume is 5.0 milliliters. My new molarity is what I'm looking for. And my new volume is now 200 milliliters. So that means that 5 milliliters of the 12 molar are going to contain the same number of moles as 200 milliliters of that new solution. And you end up with M2 being 0.3 molar. And I got that by taking 12 times 5 divided by 200. Let's try another problem. It says, how would you prepare 250 milliliter of 0.60 molar aluminum sulfate stock solution? Sorry. You want to prepare 250 milliliters of 0.60 molar aluminum sulfate solution from a 20 molar aluminum sulfate stock solution. So this problem is actually more practical. Let's say that I need to do a lab, and to prep that lab for you guys, I need a liter of 1 molar HCl. Well, we don't buy 1 molar HCl because we use a lot of solutions in this lab, and it would cost a lot of money to ship that much. And so what we do is we order the very concentrated solution. So we get this big jug that's like 2.5 liters of 12 molar HCl, very concentrated. And I take just a little bit of that concentrated HCl, add water to it to make the solutions that we need for the lab. And so if I want just 1 molar, and I need, like, let's say a liter of it, and I have this big, huge jug of 12 molar, well, I don't want to dilute that big jug because that would be wasteful, right? I only want to use a little bit of it. I just need to use what I need. So I need to do some math, some calculations to figure out how much of that concentrated HCl I need to use and add water to it to make the 1 liter of my dilute solution. So this is a problem that's similar here. I have very concentrated 20 molar solution. I want to know how much of that solution I need to use, of the 20 molar solution, to make only 250 mils of 0.60 molar solution. So since it's a dilution problem, I'm going to use the dilution equation. There we go. M1V1 equals M2V2. Again, it doesn't matter which one you call as 1, which one you call 2. I'm going to say this is my 1. So 0.60 molar times 250 milliliters equals 20.0 molar times V2 is what I'm solving for. Again, I'm solving for what volume of the really concentrated stuff I need in order to add water to it to make my new solution. So you solve for V2 by taking 0.6 times 250 divided by 20, and that gives you 7.5 milliliters. So that's our answer. Now it's important to be able to do the calculation, but it's also important to know how to prepare this solution. So what you would do is you would take a volumetric flask, and in this case we want to use a volumetric flask because we know the volume of our entire solution, right? Our entire solution, solvent plus solute together, needs to be 250 milliliters. That's the solution that we're trying to make. So we need to find a volumetric flask that is 250 milliliters. So I'll pick this flask. You want to get your stock solution, the 20 molar, and you want to measure, let's look at the number here. We want to measure 7.5 milliliters of it. So this is not aluminum sulfate, this is copper sulfate, but I'm pretending that it's my 20 molar aluminum sulfate, the really concentrated stuff. I'm going to measure out 7.5 milliliters of it. So I place the 7.5 milliliters in my flask, and then what I do is just add water until the mark. So, if you remember last time when we made a solution in a volumetric flask, we filled it halfway and swirled. We don't need to do that here because it's already dissolved. It's already a solution, right? So I just need to add water until the mark because together my whole solution needs to be 250 milliliters. So again, you want to be eye level with it. Bottom of the meniscus needs to be at the line. You stopper it and invert a few times, and that's how you make your solution. So let's write down these procedures. So you would measure 7.5 milliliters of 20 molar solution and place it in a 250 milliliter volumetric flask. Add distilled water until the 250 milliliter mark. Stopper and invert a few times. And that's how you make your solution. So just a reminder, when you are making a solution of a certain molarity, or when you are diluting a solution, both of those cases you use a volumetric flask, because in both of those cases you know the volume of the total solution. When you are making a solution that has a certain molality, you do not use a volumetric flask because you need to measure your solvent and your solute separately. Have a wonderful day, guys.